alright ทุกคนพร้อมนะครับเข้ามาประมาณ10 เพลงหยวนๆนะครับwe're going to use the same technique same method which is your signature okay written in the chat box in the Zoom, right?สำหรับคนที่สะดวกที่อยู่ YouTube นะครับก็อยู่ที่หน้า YouTube แล้วก็พิมพ์ตรงนั้นมานะครับบางทีผมอาจจะไปกรอดูที่ YouTube ไม่หมดครับคุณก็รบกวนผมก็รบกวนคุณนะครับแคปเจอหน้าจอมานิดนึงนะครับใช่ไหมครับเพื่อว่าป้องกันการพลาดอย่างวชิรวิทย์อะไรอย่างเงี้ยครับก็เริ่มพิมพ์มาแล้วนะครับ right yeah yeah we will start soon our lecture okay because I let you have the break already, right? And M604 has finished it quite earlier, right? Oh, sorry. Right. Yes. Okay, when everything is fine, we are gonna start our lecture right now. It's something about the talk. Okay, talk is also known to you earlier as the moment, right? The moment in physics, right? Moment is the force multiplied by distance, right? It's the product between the force and the moment. Okay, in yeah, you could get the outcome, the force and the distance, and you get the outcome as the moment, and it is also known as torque. Okay, in realistic application, for example, in engineering, we would say it's torque. Okay, but actually, it corresponds to the quantity in physics, which is known as the moment. Okay, moment is the product between the force and the distance. All right, I hope that everything is fine. Okay, I have to send, but that channel is not so strong. I think it's not so smooth, but anyway, if you want to see it, but the channel that is transferred from the Zoom will be the best case. Okay, if you don't want to stay in Zoom. Right นะครับเริ่มพิมพ์ชื่อนะครับที่ในแชทนะครับที่แชทของมันอาจจะไม่ค่อยสมูทนะครับในช่องนี้นะครับyeah you can start typing your name in the chat box in the Zoom. All right, and we would we will start soon our lecture on page 108. Okay, the new story to us is on 108. That is the... Okay, and I have to share the file also to you, right? This one, SMS. SMS, the M604. All right. PDF, right? Yeah. Is that correct? I would need to send it to you. Yeah. Now let's continue our story. This is the new topic, which is talk on the current loop. We still have few topics to go ahead in order to complete this chapter. Yes. Why? อันนี้แชร์อย่างนี้ไม่ได้ต้องแชร์ okay. Link send to you M605, right? In everything, okay. Every person. Export. Export. Right. Yeah. We have a conductor and we leave it in a square shape, okay, but we can't send it. I'm going to use the wireless link. X1. X5G. In yeah. This one M605, right? Because the file is quite large. All right, and now here we will talk about our story. ฝนตกนะครับใช้ Wi-Fi ครับกลัวสัญญาณในเน็ตมันจะเจ๊งนะครับ All right, here are the square shape, right? The rectangle shape. I'm sorry for that. It's a square shape, and we will see what is going on with this square shape if we have a magnetic in that area, magnetic field, right? The vector B, as you have seen, as you can see here, the green one. All right, and this is the square shape, but it's the ideal, okay? The most possible way is that you have the input side, okay, and the output side. Okay, the input side and the output side like this, okay, and you let the current flow in this direction, okay. You can connect it through any water source. It's for simplicity, it's gonna be direct current source, okay, like that. This one. Okay, it can be a direct current source like this, okay. You connect the positive side or the positive polarity to one conductor, and it start to connected to this it is further connected to this conductor by, right? It can be made of aluminum, copper, or any type of metal. All right, and that's the case for us. Yeah. Yeah, the currents will flow in this direction ถ้าใครผมลืมกดให้เข้ามีอีกไหมครับมีไหมไม่มีนะครับก็เหมือนเดิมนะครับพิมพ์มาที่กดที่ตรงไหนที่ตรงนี้นะครับก็คุณก็พิมพ์มาอย่างนี้นะครับพิมพ์ชื่อมาเหมือนเดิมเรานะครับเพื่อไม่ให้ประหยัดเสียเวลาครับโอเคyeah our story is here alright yeah the currents start to flow at the input side here okay but important thing is the square shape the rectangle shape of the whole conductor the current will flow from this one okay from the upper side of the rectangle it start to be to flow along the left side of the rectangle shape of the conductor and at the same time there is magnetic field okay for any source I don't know it can be from conductor of that's the magnetic field on earth but the magnetic field on earth is quite light it's not so strong okay so yeah ผมแชร์ไฟล์ที่ Good Notes ไปให้ด้วยนะครับเผื่อมันอัปเดตแล้วคุณอยากจะเขียนจะแก้คุณจะถามผมแล้วแบบว่าต้องการวาดรูปอะไรอย่างเงี้ยนะครับโอเคไหมคุณจะวาดรูปให้ผมดูผมคิดอย่างนี้ได้นะครับโอเคไหมคุณก็วาดรูปไฟล์มาแล้วก็เปิดเทียบกันครับเพื่อว่าไฟล์จะได้อัปเดตเผื่อคุณอยากถามนะครับมันอยู่ไกลกันก็ต้องใช้เทคโนโลยีใช้วิธีสื่อสารทางเทคโนโลยีแบบนี้นะครับพยายามทำให้ได้มากที่สุดเท่าที่ผมรู้เรื่องนะครับโอเคไหมครับyeah that is magnetic field which is denoted by the green arrows here okay from left to right okay it's directed horizontally like this okay and because we are quite far from the source of the magnetic field the line here the magnetic field lines are parallel okay to each other and it's uniform okay there is no spatial density of magnetic flux in each location okay all the area here will receive the same amount of magnetic field เสียงใช้ได้นะครับโอเคไหมผมเทสดูก่อนokay that's okay เสียงใช้ได้อยู่that's the first or the more the simple assumption we have to apply to assume okay otherwise we will get trouble and when the magnetic field is not uniform it will be beyond your scope okay we need to use the calculus especially the integration well สำหรับคนที่ขอนะครับเดี๋ยวเตือนผมด้วยนะว่าอาจารย์สรุปเป็นภาษาแต่อย่างนี้6 โมงเย็นนะคุณ605คุณเตือนผมด้วยนะก่อนที่จะยกเลิกคลาสบางทีผมอาจจะลืมว่าเขาเขียนมาบอกว่าให้สรุปเป็นภาษาไทยให้ด้วยความยินดีเลยครับโอเคไหมแต่เวลาอาจจะเลยนิดนึงหรือว่ายังไงก็แล้วแต่ครับคนที่จะควิดคุณจะเลิกก่อนก็ออกไปก่อนได้นะครับโอเคไหมแต่สำหรับคนที่อยากจะฟังสรุปภาษาไทยผมจะพูดให้นะครับโอเคไหมสำหรับเลคเชอร์ในแต่ละครั้งครับ605นะครับเพราะว่าคุณไม่มีเวลาเป็นข้อจำกัดนะครับหลังจากคุณไม่มี60อะไรต่อไปนะครับไม่เหมือน604นะครับ alright here you have the magnetic field moving through this rectangle conductor in yeah the current will flow in any way as they could go okay there is no other connection so there is only connection to the right it's gonna the current is going to move like this okay actually electron but in the opposite direction and it moves further upward like this and it returns and get back out of the whole area here in this direction okay it reaches the negative side or negative polarity of the source okay but they don't talk about that but this is the whole detail whole story of this thing all right let's say the short side okay, the short side of the rectangle is of the width A, okay, and the long side of the rectangle is of the length B, okay. That's a typical shape of the rectangle. In yeah, as you may have heard before, we have studied or we have considered the story about F equal ILB, right? F I L B, right? That's the formula in order to determine the induced force direction, right? For example, if you have L here, right, in this direction, and you have B here in this direction, right? Just the step is that the technique is that you have to start from the first vector, the direction of the vector L, to the second vector, which is vector B, and you curl or rotate your four fingers from the first vector like this, and your thumb direction, okay, that's the most important thing, the thumb direction to this rotation is gonna give you the direction of the induced force vector F, okay, according to this formula. Okay, don't talk about, don't pay attention to I is only the magnitude of the vector L, okay. Yeah, that's the thing you have seen before, right? In let's take a look at this I, right, and B. You will find that ILB sine theta. Okay, the scalar version of this expression is FILB sine theta, right? Sine theta or sine phi, up to you, right? Theta is the angle between vector L and vector B, right? Because that's the result from the cross product of two vectors. And you would find that when I is moving like this and B is moving like this from left to right, this one from right to left, the angle between them is gonna be 180, right? This the combination of these two vectors, it's 180, and you will find that sine of 180 is sine 180 เท่าไหร่sine 180เท่าไหร่เนาะมันคุณเรียนวิชาคณิตศาสตร์มันต้องใช้ด้วยครับที่นี่นะครับเห็นไหมมันเกี่ยวข้องกับฟิสิกส์ด้วยแล้วก็นู่นครับใช้ถึงปริญญาตรีปี3ปี4นะครับเห็นไหมจนsine of 180 is gonna give you 0, right? So it means there is no force at all in this location. เชิญครับก็ไม่เป็นไรครับไม่เสียหายไม่เป็นไรครับตามสบายเลยครับคุณดูที่หน้าจอครับเข้ามาที่แชทลิสต์ตรงบ็อกซ์ตรงซูมนะครับตรงเนี้ยครับตรงเนี้ยที่เพื่อนๆเขาพิมพ์กันเห็นไหมครับเนี่ยคุณหมายเลข20ใช่ไหมผมเห็นคุณ20แล้วก็ชื่อแรกนะครับแล้วก็ชื่อวาเลนทอนเรียบร้อยครับแค่นี้แหละครับโอเคไหมครับด้วยความยินดีครับดูที่ไลน์กลุ่มของห้องผมส่งให้2ลิงก์นะครับมี2อันนึงที่ภาพชัดๆมันจะกระตุกผมส่งให้ไหมไม่ส่งให้โอ้ my god I'm sorry for that oh sorry I didn't send you the link in the YouTube ผมไม่ส่งส่งหน้าผมก็ว่าส่งอยู่นะส่งให้อีกรอบหนึ่งครับไม่รู้ใช่หรือเปล่านะส่งแล้วเนาะโอเคมันมี2ช่องครับคุณเลือกเอาช่องที่คุณดูแล้วสบายตามที่สุดเพราะว่าอินเทอร์เน็ตมันไม่แรงครับTrue เขายังไม่มาเดินสายไฟเบอร์ให้ผมนะครับอันนี้เป็นตามสบายครับคุณเช็คชื่อในแชทในซูมแล้วคุณก็ออกไปที่ YouTube ก็ได้หรือว่าคราวหน้านะครับคุณบอกว่าคุณไม่อยากเข้ามาในซูมคุณอยู่ที่ YouTube ตรงหน้าไหนก็ได้แล้วคุณพิมพ์ชื่อเคาะลงไปในแชทในไลฟ์ของ YouTube นะครับแล้วคุณก็แคปเจอร์หน้าจอนั้นนะครับมันจะสแตมป์เวลาอะไรของคุณด้วยนะครับแล้วก็ส่งเข้ามาในไลน์กลุ่มนะครับเพราะว่าเสร็จหลังจากนี้ผมจะได้ลงคะแนนเข้าเรียนให้คุณนะแล้วผมก็ต้องแจ้ง อะไรหัวหน้า EP อะไรเขานะครับแล้วก็ส่งให้คุณด้วยนั่นแหละโอเคไหมครับแจ้งคุณครูโคอะไรประจำทุกครั้งอย่างเงี้ยนะครับโอเคไหม alright so let's get back to the detail of our story the in the upper part of this square rectangle you have side 180 right there is no force exerted on this portion this part this component at all okay and on the upper part of the rectangle but what about this the left side on the left side you have the vector L like this right that's the vector L and vector B is gonna be like this right this the vector B all right and in the typical way we have to rotate our four fingers okay except for the thumb okay you rotate or you curl your four fingers from the first vector which is vector L right according to this formula from the first vector to the second vector which is vector B right and you will find that your thumb direction will give you คุณห้ามดัดมือพิเศษนะเอามือแบบธรรมชาตินะครับโอเคไหมห้ามนิ้วแบบลำไทยนะครับโอเคคุณกำมือธรรมดาโอเคไหมครับ your four fingers will it gives you the thumb direction like this and its direction of the thumb is going to point out of this plane and we get the dot symbol here which represent the head okay or the front view of the arrow or of any vector right everywhere here you get the force out of the plane of this lecture note or your monitor right you will get all the force in this these components okay and what about this the lower component what is expected what do you think whether we should have the force on this component or not คุณคิดว่ามันจะมีแรงเกิดขึ้นไหมข้างบนไม่มีแรงนะไม่มีแรงเกิดขึ้นนะเพราะว่า sin 180เป็น0 what do you think here whether we will have the force in this one or not what do you think then คิดว่าเป็นอย่างไรครับ of course it's the typical way if you use the I'm sorry ผมขอเช็คif you use the conventional way ILB sine theta you will find that at this component the lower one you have vector L pointing like this okay that's the vector L and of course again we have vector B in this direction as well okay that's the vector B so the angle between vector L and vector B is 0 right so when there is no angle at all so it means 0 degree of angle between B and L so sine of 0 is gonna be 0 so there is no force happening on this bar at all right there is no force here and also no force here rightมีอินเทอร์เน็ตพอปนะครับ Where's this one? Okay let's move to the last part which is this one the vertical one and we can see that ไม่ทราบว่าสัญญาณผมดีหรือไม่ดีนะครับyou can see that here we have vector L directed in this direction that's the vector L right and the vector B is gonna be here right pointing from left to right all right and yeah we have to follow the same manner we start from the first vector to the second vector right we rotate our four fingers from the first vector L to vector B you will get the outcome okay on the left side of this equality which is the vector F okay the induced force on this component okay this bar and you will find that your thumb direction will point downward or into this plane, right? And in order to draw three-dimensional inอย่างรวิพลครับรวิพลก็พิมพ์มาที่ YouTube นะครับก็เดี๋ยวผมแคปเจอร์คือกันเหนียวไว้ด้วยนะครับก็คุณก็แคปเจอร์แล้วก็ส่งหน้าจอนะครับถ้ากลัวพลาดนะครับถ้ากลัวพลาดก็แคปเจอร์หน้าจอแล้วก็ส่งมาในไลน์กลุ่มด้วยก็ได้นะครับ alright and that's it in yeah the force here okay will be directed into this plane. So what we can see in 2D is that we can see only the rear part or the tail of that vector of that arrow. So we write down the x side or the cross side here. All right, that represent the tail of any vector, right? We have here the dot, that's the front view. Okay, the front side of the vector, right? That's the front side. And the cross side, okay, the x side is the rear side or the tail, right? Rear side คือด้านหลังของเวกเตอร์โอเคไหม rear side of that vector. All right, for any vector, right? But here the main interesting quantity for us is the vector f, right? Okay, you will have all vector f pointing downwards on this bar. Okay, the vertical bar on the right side of this conductor like this. Okay, pointing down, pointing upwards. So what happens if we have the force that try to keep this one up, okay, and the force that try to make this one down? What do you think? There is no force at all along this component here. Okay, there is no force acting on these two bars, but there are two group of forces acting on the left and the right side. What do you think then? Of course, ขอใช้กล้องนิดนึงno oh sorry for that. How could I oh no my god. Okay, making right direction. Alright กลับไปอีกรอบนะครับ อินเทอร์เน็ตหลุดนะครับมันฝนตกนะครับ alright yeah if not we're gonna replace this one, okay, by using only the same card. And yeah, here is the technique. Is that all right? ใช้ได้ไหมครับ okay here BDSK. all right, okay, you have the force, right, like this, and yeah, one try to keep this side up, and one tries to another group of force try to bring this one down, right? ขอเช็คเสียงก่อนครับว่าเสียงยังมาอยู่หรือเปล่า alright มาอยู่นะครับhere one try to keep this bar up and one tries to keep this bar down, okay, make this down, so there will be rotation to this one, okay, to this conductor loop or bar, okay, if we take a look at the side view of that conductor loop. All right, and that's the case the case that is going to happen. ผมก็ไม่รู้ว่ามันหลุดไปตอนไหนนะครับ ใช้ทั้ง Wi-Fi ใช้ทั้งอันนี้นะครับyeah let's get back to our lecture notes. We move to the figure 48, okay, on the next page 109, and here is the side view, okay. What is the side view when I often say side view? Okay, let's get back to the zoom again. Okay, side view, what is that? พูดเป็นภาษาไทยแล้วกันนะครับกล้องเห็นนะครับโอเคalright ไหนดีside view แก้วอันนี้แล้วกันกาน้ำนี่แล้วกันครับเห็นไหมครับกาน้ำครับทุกคนเห็นนะครับถ้ามองด้านข้างครับคุณก็จะเห็นเป็นรูปทรงอย่างนี้เห็นไหมเห็นเป็นรูปโค้งมีรูปดูด้านข้างมันก็จะเป็นภาพ2 มิติของมันใช่ไหมมันจะมีรูปโค้งรูปปากของกาต้มน้ำแล้วก็มีฝามันนะครับถ้าคุณเปิดฝาก็จะเป็นฝาเปิดอ้าอยู่อย่างนี้นะครับโอเคไหมแต่ถ้าI'm not sure whether you can see it properly alright yeah no alright yeah alright here ถ้าคุณมองเฉพาะด้านข้างครับคุณก็จะมองเห็นรูปทรงมันแบบนี้นะครับแต่ถ้าคุณมองด้านบนของมันนะครับมันก็จะเป็นอีกแบบหนึ่งโอเคครับเขาเรียกว่า front view ก็คือ top view นะครับก็คือมองข้างล่างลงไปข้างบนข้างบนลงไปข้างล่างครับแล้วก็ side view ก็คือถ้า side view ด้านนี้ครับก็คือคุณก็จะเห็นด้ามมันนะครับแล้วคุณก็จะเห็นข้างๆเห็นฝาง้างมาแบบนี้นะครับในขณะที่ด้านนี้นะครับถ้าไซส์วิวแบบนี้คุณก็จะเห็นปากที่ริมนะครับแล้วคุณเห็นฝาของมันที่เปิดค้างไว้นะครับก็เนี่ยด้านข้างแบบนี้นะครับการมองเข้าไปแบบนี้เรียกว่าไซส์วิวนะเวลาผมพูดนะครับเขียนมามันเป็นมุมมองพื้นฐานนะถ้าคุณเรียนเขียนแบบวิศวกรรมนะครับมันก็จะมีไซส์วิวท็อปวิวก็คือมองบนลงล่างก็อันเนี้ยมองจากข้างล่างขึ้นบนก็มีครับมีหลายมุมมองใช่ไหมแต่ว่าของเราเนี่ยมีแค่ด้านเดียวครับ side view in figure 48 alright if you take a look at figure 48 which is the side view of figure 47 or the previous figure. Here is the top view of the whole conductor, right? Saying this one is going to be the side view. Okay, if you take a look and you have your eyes like this, okay, and here is your eye, okay, and you take a look at this one in this direction, you will see the figure in this way. Okay, all right, and yeah, one side of the conductor has the force that try to keep it upward, okay, lifting force, and another side of the conductor here is the place where you can find the pushing force, okay, the force that try to make this side going down, okay, going downwards like this. And yeah, as I told you in the camera, this bar is going to rotate, okay, and when okay, forget about it. If the force here is pointing up, okay, it means this object is like this one, okay. You have an object and there are two forces, this force F1 and F2, okay. Try to keep this object up, so this object is going to move upward, okay. And if they have M, we are going to apply the Newton law, which is sigma F ma, right? You would be able to determine the acceleration of this mass, right? But this is not the case, because one side has the lifting force and another side has the pushing force. This is this will give you the rotation of this object right นะครับสรรพสิ่งในสเปซในจักรวาลมันก็จะมีเคลื่อนที่ตรงเคลื่อนที่แบบหมุนมีอยู่2อย่างเนี่ยนะครับโอเคไหมวิชาฟิสิกส์ก็จะพยายามอธิบาย2สิ่งนี้ alright and that's the case well there will be rotation of these one and as you may have seen in Matheum 4 or Matheum 5 that is the so-called moment right moment or even in Matheum 3 moment is the product between force and distance right the distance that you that the force is going to take place okay distance from the rotating point okay which is this one they use the alphabet O which represent the origin or something like that or 0 position okay in English they would say is pivot okay pivot is the rotating or the referencing point all right and yeah you will have this point as the reference and of course this is the moment that try to keep the whole object here rotated in the clockwise direction okay this is the clockwise direction right and here is the anti-clockwise direction right or the counterclockwise CCW right counterclockwise direction or anti-clockwise direction doesn't matter but the force here is the is the part of the moment to make this object rotating in the clockwise direction so we would say it's moment in the clockwise direction so moment is the word known in physics but in engineering we would call it it's torque right it's torque all right it's torque and it's represented by the tau symbol tau letter and it's going to be F1 right the magnitude of F1 times the distance between the force to the and the rotating point which is okay the whole length here is A right but according to the symmetry the rotating point is going to locate at half the whole length here so this one okay the distance from the first force to the rotating part is going to be A by 2 so F will be the multiplication torque will be the multiplication of F1 okay the left side to the distance that you have the force okay with respect to the rotating point is going to be A by 2 right but it's not only the one source of moment okay there is another moment as well and it's in the same direction okay if this one is pointing up okay we're gonna say it's negative okay but when it's the accumulation okay the summation here okay because it just increase the moment in the same direction so it's going to be plus okay as we know before a moment is a force multiplied with the distance so it's the name of the force on the right side is F2 right F2 times the distance okay because of the symmetry the distance here is again A by 2 all right here that's the way you have for this figure all right ผมเป็นอะไรผมขออนุญาตเข้าห้องน้ำนิดนึงครับเดี๋ยวกลับมาต่อเวลาให้ก็ได้ครับ All right. Okay. Let's get back to our story. That's the case when the conductor loop in rectangular shape laying like this. Okay. And of course, if you go further, you find that a by 2 is the common term, right? They both are the same, are of the same value, so we have a by 2 and f1 plus f2. All right, but if you go further, you will find that f1 and f2 actually have the same magnitude. Okay, f1 and f2 will have the same magnitude. You will see the detail later. And let's say f1 and f2 is equal to f, okay, without any subscript. You get a by 2 and here 2f, right? And of course, number 2 here will cancel each other. You will get a times f, right? Yeah, it's quite simple. A is the length of the conductor here, right? F is the amount of the magnitude of the force on each side, okay? And F can be found later if you can remember the story that we have talked earlier, right? It's F is equal to ILB sine theta. And what is theta actually? Theta is the angle between L and B, right? Vector L and vector B. So that's the case, okay? Here it's general expression in terms of F. But what is the situation when we have, of course, this object is going to rotate in clockwise direction, and what is the torque at the moment where we when the bar is tilted? Okay, it's not simply laid on the plane like this. Okay, it's tilted a little bit by angle theta. Okay, theta here. All right, and let's see what is going on with that. Yeah, you will find that theta here is measured is the angle between the normal vector of the plane to the magnetic field. Okay, and so let's me give you the idea of what the normal vector is. Here you have the plane, right? ภาษาไทยเรียกว่าระนาบ okay ไหมครับ okay, you have the plane and the normal vector is the vector that is start or directed out of this plane, and the special thing of this vector, which is unique, okay, which is distinct from any vector. Okay, you can have any vector, this direction. Okay, there are many vector, there are many possible way of vector, but the red one here is the single and unique vector that has angle of 90 degree in any direction. Okay, this is 90 degree, this is 90 degree in any direction to that plane. Okay, and this one is called normal vector. Okay, the vector that is perpendicular to the plane. Okay, sorry for that. Normal vector. All right. Yeah. The angle theta is the angle between the plane normal vector to the magnetic field. Okay. And yeah, FILB sine theta in that expression is different. It's the angle between L and B, but in this one they use the same alphabet, but the value of theta represents a different thing. It's the normal vector, a normal line to the plane. Okay, you can see here a normal line. The angle between these one is 90 degree. All right, here as well is 90 degree. Okay, that's the normal line or normal vector. Well, yeah, at the moment when the conductor loop is tilted, okay, is bent a little bit, is tilted actually, is at the location of angle theta like this. All right, and what is the torque that happens in this scenario? Of course, the definition of the moment or the torque is the force time distance, right? But at this moment, but the important thing is that the force and the distance you measure should be 90 degree or perpendicular to each other. Okay, it does mean that you have F here and you multiply again with A by 2, okay, because the force is not perfectly perpendicular to the loop anymore. Yeah, okay, the force doesn't the force is not directed in this way anymore, okay, because it's lifting force. The force should be all the time vertical like this. All right, it's not this one, okay, it's not this one, not this one. All right, so we have to recompute or compute the moment again, and what we may observe is that this is the distance between the force acting on the rotation, and this is the amount of the force. The amount of the force should remain the same, okay, because the shape of the copper wire doesn't change, okay, it's a rigid object, so the copper wire is not bent, okay, it has the same length, so the amount or the magnitude of the force should be the same, remain the same. In but the different thing is the difference is the distance between the perpendicular force to the rotating point or the pivot here, okay. As they define, okay, theta is the angle between the normal line or the normal vector to the magnetic field directions. So this is theta, and you can see that the reflection of that angle is going to be here, angle theta. And of course, this is 90 degree, right? This is 90 degree. The angle here, right? The angle here is going to be 90 degree minus theta, right? And in this triangle, when you have here 90 minus theta, what is the angle at this corner? What is the angle at this corner? What is the value of this one? This one is going to be 90 minus 90, right? 90 degree minus 90 degree minus theta, right? It's going to be only theta, right? So this is theta, and if we draw a conventional Pythagoras of right angle, a triangle, you have here theta, and we would like to know the distance here. What is this value? And here we know that this one is A by 2, right? So this side, okay, this side is going to be A by 2 psi theta, right? And that's the case. All right, it's nothing surprising to us, okay, just a simple Pythagoras theorem. In yeah, you know now that the distance here is A by 2 psi theta, right here, okay. And we get back to the moment computation force, the force that is perpendicular to the measurement of the distance times the distance. So we have right now torque is going to be force should be the same F1, right? But the distance to compute the moment now changes to A by 2 and psi theta, All right, that's the on the left side, and on the right side you have the another f, which is f2. Okay, but if you go further, you find that f1 and f2 have the same magnitude. And of course, the distance to compute the moment is this one, right? It's no longer a by 2 anymore. Okay, and if you project everything, you'll find that distance here will be the same as the distance here on the left side, and of course it's going to be again a by 2 psi theta, right? That's it. And of course we have two sources of the moments, so we have to add them together, and it's positive side because it's keep the object rotating in the clockwise direction. Okay, it's accumulation. Okay, it's the addition way. So we have here the plus side f2 times again a by 2, oh sorry, a by 2 psi theta, right? And of course a by 2 psi theta is the common factor. You have a by 2 psi theta now plus f1 added to f2, right? And that's the result. And if you go further, you find that f1 and f2 are equal in magnitude, so this is going to be 2f, right? A by 2 psi theta and 2f. What is the result? Then we're going to have the cancellation of number 2's at both positions, so we get a times f and psi theta like this. Okay, what is the difference then? Here we have AF, right? Torque equal AF. Okay, when the angle between the normal vector and the magnetic field is right angle is 90 degree, and when the normal vector of the plane is made with theta, angle theta to the magnetic field, we're gonna have AF psi theta. Okay, not simple number one here. And yeah, this is the derivation. If you go into the detail, you find that ILB, what is that? This is the length B, right? The left side, and the right side here is the length of the rectangle side, which is B, right? The long side, it's this B, right? And I, of course, I is the current, the magnitude of the current flowing in this way, right? ILB. L is B, right? The length of the component of the conductor that has the force, right? Are those two vertical bars. So the length of this one is B, right? And B is the strength of the magnetic field, right? It's going right there, right? B, right? So if you substitute it into FILB, right? Actually, ILB is like theta also, but theta is different way. It's the angle between the length, the vector L and vector B. So in this case, you find that it's 90 degrees, so there is no sine term at all here. It's simply number one. So IB, B, okay, I small b and I capital B, and you substitute it into the original expression, and you will get number 2, factor 2, okay, in front of that, and 2 and 2 will cancel each other, and what you will find is that the product between A, okay, what is the problem? Any internet connection to that or what? Yeah. If nothing is no error happens, so we're going ahead. You will arrive at the term A times B. Okay, A times B. A times B, what is that? Of course, we have the rectangle like this, right? And, oh, sorry. Here is of length A, right? And on this side, we have the length of B. Okay, and the long side, B. On the short side, A. Okay, and you may get to know already in your primary school, this is the area of the rectangle โอเคก็คือพื้นที่ของสี่เหลี่ยมผืนผ้าครับโอเคไหม so AB is the area of this rectangle and it means that we won't express it in terms of small a and small b anymore. Okay, we simply say it's the area of that of this conductor that occupies. Okay, this the blue one is the conductor. This conductor occupies the area like this, a rectangle. Okay, and we would have AIB sine theta, or you may say it's BIA sine theta. And some of the physicists have defined it quantity which is called mu. Okay, mu, the Greek alphabet, which is the coefficient. Okay, in order to get the torque. All right, it's simply the product between current and the area of this conductor. Okay, the area and the current flowing in that conductor, right? So you can say it's a b I sine theta. Okay, RB, you can say it's RB. I don't know which way you are gonna use to remember, or you prefer this one, I B A sine theta. Okay, any term, any form of this is going to give you the same result. Okay, because there is no order in multiplication. Okay, there's no order priority in multiplication. Okay, any sequence of this multiplication will give you the same answer, the same quantity. Or you would say it's BIA sine theta. Okay, please pay attention to this because this will serve as the basic, because there is another more complicated topic about that when we have several turns of the conductor. Okay, many numbers of turns of the conductors. So you may prefer try to remember this formula by saying that RB sine theta, or E bar sine theta, or BR sine theta. But for me, I prefer the word BR. Okay, because we are going to have N later. Okay, during my high school time. Okay, I have also attained a special school. Okay, apart from the official school, they would say EBA. Okay, but later when they have additional factor, additional term, which is N is the number of turns. Okay, the number of conductor turns in this one, there will be capital, and they would say I-bar. Okay, IBAN, I-bar. And it's two words, right? Here, BIAN, bian. Okay, it's quite simple. It's only one. Okay, we will see the factor in later. Okay, for a single loop of the conductor, it's here according to the topic, a current loop. Okay, a single current loop will give you BIAN sine theta, or IBA sine theta, or ABI sine theta. It depends on the angle, how the conductor loop locates. All right, now let's move to the next result. Okay, even the formula RB E bar BR sine theta, or with sine theta, is derived from the rectangle. What is that? The time is we still have 16, right? It's 15:40, right? We still have 26 minutes. Okay, that's fine. ถ้าหลังจากนั้นนะครับคุณจะอยู่ต่อฟังสรุปเป็นภาษาไทยให้ก็ได้นะครับเดี๋ยวผมสรุปภาษาไทยให้แล้วเพราะว่ามีคน request มาส่วนตัวนะครับเคยมาห้อง605ก็จะสรุปให้นะครับ alright yeah we arrive at the sentence. Okay, even the analysis here is derived from the rectangular shape of the conductor loop. This expression RB E bar BR sine theta, or with sine theta, is valid or holds true to any shape of the conductor. Okay, if you have triangle, you want to have the conductor in triangle shape. Okay, it's triangle. Number 2, right? Yeah. Or you want to have in circle shape. Okay, circle. Or what else? If you want to have it in the square shape, okay, all 4 sides have the same value. It's square, right? It's square. Okay, or you want oval like this. Okay, ellipse. Or what else? Or you want a heart. Okay, a heart shape of your conductor. Okay, it's possible. Or any shape. Okay, this formula is valid to any shape of the conductor. Okay, the most important thing is that you should know the area that is covered, okay, or surrounded by the conductor, right? The important thing is the area. Okay, if you know the area, then you can leave it into this expression and you get the torque. Okay, the amount of torque. Let me ask you as a private question, okay, which may not fully or 100% related, may not be fully related to our story, but it's in engineering sense. If you have 1 meter of the conductor like this, what kind of shape could we get the best or the maximal area in order to build up the conductor loop คำถามก็คือถ้าคุณเขามีอนุญาตให้คุณมีเส้นลวดได้ยาว1 เมตรความยาวมีจำกัดโอเคไหมครับคุณเพราะว่าวิศวกรรมก็คืองานที่ใช้ทรัพยากรที่มีอยู่จำกัดบนโลกนะครับเพื่อเอาไปสร้างประโยชน์ให้กับมนุษย์นะครับหรือว่าในขณะที่ราคาของสินค้าของค่าของวัสดุนะครับมันก็ต้องทำให้ต่ำลงด้วยนะครับมันเป็นเศรษฐศาสตร์ผสมกับวิทยาศาสตร์นะครับเกี่ยวกับวิศวกรรมก็จะประมาณนี้แต่ว่าเราต้องการประสิทธิภาพสูงที่สุดนะครับคำถามก็คือคุณคิดว่ารูปทรงอะไร rectangle สี่เหลี่ยม triangle สามเหลี่ยม circle วงกลม square สี่เหลี่ยมจัตุรัสอันเนี้ยวงรี ellipse หรือว่า oval แล้วก็หัวใจหรือว่ารูปทรงอะไรก็ได้ที่คุณคิดได้รูปทรงกระยึกกระยืออะไรมั่วๆก็ได้อย่างนี้ก็ได้ขอให้มันเป็นครบรอบเป็นรูปคุณคิดว่ารูปทรงอะไรที่จะทำให้เกิดทอร์กมากที่สุดเกิดทอร์กมากที่สุดก็คือเกิดอะไรครับแน่นอน B มันทำอะไรไม่ได้แล้วเพราะว่าสนามแม่เหล็กมันวิ่งถูกจำกัดโดยสิ่งภายนอกกระแสเราก็สามารถสั่งให้กระแสแต่ถ้าเพื่อความแฟร์สั่งให้กระแสไหลในแต่ละเชฟเนี่ยเท่ากันแล้วก็ A มันไม่ได้มันขึ้นอยู่กับว่าเราสร้างเส้นลวดเป็นรูปทรงอะไรเป็นรูปอะไรอย่างเงี้ยนะครับเป็นสามเหลี่ยมเป็นวงกลมสี่เหลี่ยมจัตุรัสเป็นวงรีเป็นรูปหัวใจหรือรูปทรงกระยึกกระยืออะไรก็ได้คุณคิดว่ารูปทรงอะไรที่ทำให้เกิด A มากที่สุดพอ A มากสุดทอร์กมันก็จะมากสุด What do you think then ช่วยตอบหน่อยผมจะรอดูที่แชทหรือว่าเปิดไมค์ตอบก็ได้ครับผิดถูกไม่เป็นไรไม่ต้องอายเพื่อนครับถามอย่างนี้เช่นเดียวกันที่604ครับไม่มีใครตอบผมก็ไม่เฉลยไม่บอกครับคุณก็ไปคิดเอาเอง Is there any answer to this แสดงว่าผมหลุดนะแต่ว่าแชทมันเซฟอยู่ใน .text นะครับเพราะผมเซฟวิดีโอในคลาวด์นะครับทุกสิ่งทุกอย่างจะบันทึกในคลาวด์แม้ผมหลุดมันก็ยังอยู่นะครับ alright แล้วฝนหยุดตกแล้วครับก็จะนิ่งนะครับสัญญาณโอเคplease give me any answer to that whether what kind of shape do you think that we could get the maximal area in this scenario in order to get the maximal value for the torque right นะครับแล้วสิ่งที่คุณเห็นอยู่ตรงนี้นะครับมันก็คือการ การทำมอเตอร์นะครับโอเคไหมเพราะว่ามอเตอร์ไฟฟ้าก็คือการนำพลังงานไฟฟ้าสร้างเป็นพลังงานกลครับก็คือแรงบิดนะครับคือทอร์กภาษาอังกฤษโอเคany answer to that หรือว่าหลับไปแล้วหรือหนีไปแล้วครับ is there any answer from you we still have 20 minutes more if not ไม่เลยมีใครตอบได้ไหมขอคิดดูก่อนอาจารย์หรือว่ายังไงคิดว่ารูปทรงอะไรที่มันจะทำให้เราได้เกิดเรียกว่าอะไรเกิดทอร์กไม่ที่สุดแรงบิดนะภาษาไทยแรงบิดทอร์กโมเมนต์แรงบิดนะครับโอเคไหมโมเมนต์แรงคู่ควบอะไรอย่างเงี้ยครับโอเคไหมมันก็แรงคู่ควบแล้วนี่ครับโอเคไหม if there is no answer from you then we skip it we move to the next topic which is the maximal value of the torque that can happen in terms of angle okay we didn't talk about the maximum value of the shape we have started to talk but you didn't deliver any answer I will leave it like that so, okay what is the possible maximum value of the torque that can happen in this scenario if you what position of the conductor that we can get the maximum value of the torque in this rotation what do you think of course it's BR right IBA sine theta right and we have to make a maximization with respect to theta if you don't understand this expression it's used in bachelor degree in master degree or even in doctoral degree this is the optimization problem just take a look simply at the nature of the sine function it's like this right it starts from 0 when the angle is 0 right like this all right you will find that here the value of the function the sine theta right this is the value of theta right here is 0 when angle is 0 right and it's maximal when theta is equal to pi by 2 right เมื่อมุมเท่ากับ90ใช่ไหม so that's the peak okay the top of the mountain okay you may argue that here is also the place we can get the maximum value of the sine function yes it's right it's theta equal pi by 2 plus 2 pi right pi by 2 plus 2 pi and so on okay not 2 pi 4 pi 6 pi 8 pi until infinity but we will consider only the first one okay the first in the first rotation in the first round of the rotation so theta is going to be pi by 2 or in terms of degree is going to be 90 right so sine 90 is number 1 so we don't have to write down at all we don't need to write down sine number 1 at all it's simply BIA or BR okay in this case in this one it is the same story but the figure is taken from another book okay they don't use theta as the letter for the angle but rather they use the letter phi okay the letter phi in order to represent the angle between the normal vector of the plane to the magnetic field direction okay theta now becomes phi okay theta is changed to phi for some books okay don't be too narrow to remember it should be all the time theta okay in some books they use the letter phi here okay the phi okay phi is the angle between the normal vector here is the normal line to the plane okay the plane covered by this character and the angle between the normal vector to the vector of magnetic field. Okay, this is the magnetic field lines, right? And when the normal line or normal vector of that plane is phi, okay, with respect to the magnetic field direction, so it's going to be the same angle that we have for theta. Okay, so phi or theta, okay, will give you the same thing. Okay, and in this figure, in some books, they didn't use A as the short side of the rectangle. They used B variable for the short side. In the former configuration, they used A, okay, letter A to represent the short side of the rectangle. And in the long side here in this book, they used A, okay, but in the former figure, they used the letter B, right? It doesn't matter, okay. Finally, you will get the same expression, okay, because when you derive it, whether it's B or A, you will get the term which is the product of A and B, and A and B is again the area. Okay, even you have B here, okay, and here is A. Okay, it's only the area of this rectangle. Okay, and yeah, we simply again use the capital A to represent the area of this rectangle. Okay, it's only A. Okay, whether you assign the letter B to be the short side or the long side. Okay, finally it's the multiplication of those two quantities. So it's simply A, the capital A, which is the area. AIB sine phi. Okay, you get something like that. All right. Whether it's theta or phi, okay, you have the same value, you have the same theory. Now we move to the next one. This is the case when the normal line, okay, the normal of this plane is pointing like this, okay, and the magnetic field is like this, so the angle between them is 90 degrees, right? So when phi or theta is 90, you will find that it's equal to 1, right? Because, and it will be the maximum location, right? Start from 0, right? Psi, blah, 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 like this, right? And here, when phi is 90 degrees, you get the maximum value of psi, which is number 1, right? And here is number 1, right? So this term psi phi is going to be number 1 or remain 1, right? So we don't need to write down at all. It's simply BIA, okay, the product of those 3 terms. So torque is BIA, okay, because phi is 90 degree, okay, the angle here is 90 degree. It's 90 degree, right? Yeah. Now, yeah, when you make the derivation, it's going to be torque max. Okay, the subscript max means the maximum value of the torque. Okay, the maximum value of the possible torque is the case when phi is 90 degree, sine 90 is number 1. So we have the remaining thing is BIA. All right, there. And what is the case when the normal vector is 90 degree, right? And this one, the normal vector of the plane is 0 degree with respect to the normal vector, okay, with respect to the magnetic field direction. All right, so yeah, what do you think then? Before we have B, oh sorry, F, no, torque, right? Torque is BR psi phi or psi theta, doesn't matter. And this one, this plane is written right there. All right, and here is the normal vector, right? And again, the magnetic field is pointing upward like this, okay, through the plane here. So this is vector B. So the angle between vector N and vector b is, oh sorry for that, we use this different. The angle between vector n and vector b is going to be 0 degree. Okay, and when you substitute 0, this one, into the sine, so what you get will be sine 0 degree is going to be 0, right? That will make the whole term here to become 0, right? So torque in this case, when the normal vector has no angle, okay, or has 0 angle with respect to the magnetic field, you will get 0 or 180, okay, you will get 0 torque, okay, there is no torque at all, and the torque is going to be called minimal value of the torque, or tau with the subscript min, okay. That's the lowest value of the torque, okay, when the plane of the conductor loop is perpendicular to the magnetic field. Okay, the plane of the loop is perpendicular. You can see the magnetic field is here, and it has the right angle. And in this case, you have the plane of the conductor loop is parallel to the magnetic field. In this case, you get a maximum value of the torque, okay, induces in this conductor loop. But when your plane is perpendicular to the magnetic field, you get 0 torque, or we would say in another words, when the normal vector of this plane is 0 degree, okay, is taken at 0 degree, or is located with 0 degree with respect to the magnetic field line, we are gonna get 0 torque in this scenario. จะเห็นว่าไม่มีคำนวณนะครับแต่ว่ารู้ว่าเรียนเรื่องของการหมุนนะครับแรงที่เกิดขึ้นครับโมเมนต์แรงคู่ควบนะครับหรือว่าแรงบิดก็ได้นะภาษาทางวิศวกรรมที่เรียกแรงบิดไปนะครับภาษาฟิสิกส์ของม.ปลายเรียกว่าโมเมนต์แรงคู่ควบนะครับก็คือมันมีแรงคู่กัน2ฝั่งข้างใช่ไหมครับ so torque will happen maximally when phi or theta equal 90 degree, then you get torque max. Okay, when theta is 0 degree or 180, you get torque min. Okay, and for any theta, for anything between 0 and 360 degree, you get torque via psi. Okay, BIA via psi, psi phi or psi theta. All right, psi theta. All right, and that's it. There is nothing different at all. There's nothing too difficult to understand at all, right? And yeah. นะครับลองเก็บไปคิดนะครับว่าคุณคิดว่าถ้าคุณเปิดบริษัทของตัวของคุณเองครับแล้วก็สมมุติแน่นอนบริษัทมันมีต้นทุนครับคุณไม่สามารถซื้อลวดที่ยาวอินฟินิตี้อันนั้นไม่ใช่คุณมีบัดเจ็ตงบประมาณที่จำกัดสมมุติคุณสั่งให้ลูกน้องคุณซื้อลวดสัก10 เมตรอย่างเงี้ยแล้วคุณคิดว่าคุณจะเอาลวดมาพันเป็นรูปทรงอะไรเพื่อให้เกิดคุณจะสร้างมอเตอร์อย่างเงี้ยให้เกิดทอร์กมากที่สุดนะเวลาคนสร้างมอเตอร์ไม่ใช่แบบเอาทอร์กให้น้อยที่สุดนะเราต้องการให้ทอร์กแรงบิดเกิดให้มากที่สุดใช่ไหมครับเพื่อไปใช้งานเช่นไปปั่นเครื่องซักผ้าไปปั่นไดร์เป่าผมหรือไปปั่นพัดลมไปพัดอะไรอย่างเงี้ยใช่ไหมเราต้องการทอร์กแรงบิดให้มากที่สุดคุณลองนึกดูสิว่าเราจะสร้างบริษัทของเราผลิตมอเตอร์ให้เป็นรูปทรงอะไรดีรูปสามเหลี่ยมรูปวงกลมรูปสี่เหลี่ยมจัตุรัสหรือว่ารูปวงรีหรือรูปหัวใจเท่ๆก็เลือกเอานะครับคุณคิดว่ารูปทรงอะไรนะครับในความยาว1 เมตรหรือ10 เมตรเท่ากันก็ได้โอเคไหมแต่ทุกรูปทรงต้องมีความยาวในการใช้เส้นลวดเท่ากันโอเค the important thing in order to determine this is circumference okay เส้นลบรูปของมันเองนะครับโอเคไหมใช้เส้นลบรูปของทุกรูปทรงเนี่ยนะครับให้บังคับให้เท่ากับ1แล้วอันไหนได้พื้นที่มากที่สุดครับโอเคไหมลองไปคิดดูนะผมถามปีที่แล้วนะเพียงแต่ว่าปีที่แล้วมันเรียกว่าอะไรอยู่ในห้องจริงอ่ะครับมันเขาก็ตอบให้ผมได้ทันทีแต่อันนี้อยู่ห้อง virtual ครับห้องที่เป็นออนไลน์ครับไม่ได้อยู่ห้องจริงๆก็คุณก็ตอบบ้างไม่ตอบบ้างครับ604ก็ไม่ตอบนะครับผมถามไปก็ไม่ตอบโอเค alright now let's move to the sophisticated version okay before that you consider the rectangle or rectangular shape of the conductor right but this one is the circular shape okay you can see that it's a lot of there is a lot of numbers of the round or turns of conductors here okay this one is called solenoid okay it's different from mechanical spring okay mechanical spring in mechanical spring you have the gap between each round right but in sinusoid we have several rounds or turns connected to each other but don't use but there should be insulator to protect the current movement from one round to another round โอเคก็คือเขาเอาลวดเนี่ยนะครับไปจุ่มกับน้ำยาเป็นฉนวนนะโอเคไหมครับป้องกันไม่ให้กระแสมันออกด้านข้างนะครับโอเคไหมแล้วเขาก็จับมาพันๆให้มันชิดกันให้มากที่สุดถามว่าทำไมต้องชิดกันเพื่อว่าให้วงกลมนั้นมีพื้นที่เป็นมีขนาดเดียวกันครับมีวงกลมขนาดพื้นที่เดียวกันให้มากที่สุดนะครับเห็นไหมชิดๆเหมือนกับเอาวงกลมมาวาดขีดซ้อนทับหลายๆรอบแต่มันซ้อนทับไม่ได้นะเขาก็ต้องพันเอาอย่างเงี้ยนะครับเรียกว่าขดลวดนะครับหรือว่าโซลินอยด์โอเคbut there should be insulator around this conductor right in